7 from Notes 2.1 on linear equations. So this problem says when rents are $580 a month, all 50 units in the apartment building are occupied. When rents go down to $625 a month, only 47 units remain occupied. Assume that the relationship is linear. So this is what we're learning in this section. And write down an equation in slope-intercept form. So slope-intercept form, that tells us what our end result is going to look like. That's going to be y equals mx plus b. That will tell you how many units will be occupied if the rent goes up to $655. So in this case, our input is going to be the rent. So x is going to represent the rent, and y, our output, is going to be the number of units. So to begin this problem, I recommend that we convert this information into points. So we want to have ordered pairs, which are going to be x comma y, which will be, in this case, the rent and the number of units occupied at that value. So here we have when rents are $580, all 50 units are occupied. That's going to give us our first point. So it's going to be $580. We get 50 units are occupied. Our second point is going to be when rents go up to $625, only 47 units are occupied. So our second point is going to be 625, comma 7. And now we've boiled this problem down to nothing more than writing the equation of a line through 2 points. In order to write the equation of a line through 2 points, we want to find the slope. So the slope is going to be y2 minus y1. So we can do 50. Oh, I'm sorry, this is wrong. This should be 47, not 7. 47 units occupied. So the slope is going to be 50 minus 47, y2 minus y1, going from this point to that point, over 580 minus 625. As long as we take the points consistently in the numerator and denominator, we're fine. 50 minus 47 is 3. 580 minus 625 is negative 45. If we simplify that by dividing out a 3 from the numerator and the denominator, we get negative 1/15. That's our slope, and it's going to be our units actually for this slope are going to be units per dollar, I guess. Now, we want to write the equation of a line in slope-intercept form. So that means y equals mx plus b. We know our slope is negative 1/15. So x plus b equals y. And there's 2 ways to do this. We can just substitute either point into this equation and solve for b, or we could also use point-slope form. Since we want to get this in slope-intercept form, let's go directly to that form. I will use this first point. I'm going to use this point here for my x and my y. So in which case, I'm going to get 50 equals negative 1/15 times x, which is 580 plus b. So I'm going to solve for my y-intercept. So b is equal to 50 plus 580 over 15. And that turns out to be 266 over 3, if you simplify that. So my equation in slope-intercept form is y equals negative 1/15 x plus 266 over 3. That's the equation. The last problem of the problem says, last part of the problem says to use this equation to predict the number of units rented if the rent is equal to $655. So we can substitute in 655 for x. So we're going to get y equals negative 1/15 times 655 plus 266 over 3. And if we simplify that, this turns out to be 45. And that's our answer. So 45 units rented with a rent of $655.